Hello everyone, this is Instructor AK from EK Technology. Thank you very much for watching this video. Today I'll be covering the official certificate of CCNA 200-301 chapter. So CCNA Certified Network Associate is an information technology. The certification from the Cisco Systems CCNA certification is an associate level. Cisco Career certifications will pass in all the chapter and also implementing the lab which is required for your IT career. So this is the Cisco Certified CCNA about. The logo you can see, which is 200-301. Thank you. Right now I have opened a lab which is according to the reference of the network. So as you can see over here, there are 4 computers and they are connected with the internet provider. Could be anything, could be Verizon, could be Sprint, Spectrum, could be any kind of internet provider. So number 1, 2, 3 and 4. So they all combine with the network and they share and the resource, the data, and also they have transferred the file and so on and so on. There are 2 types of network, as you can see over here, the physical address and also logical address. So right now we can see that physical address they combine with the hardware, which is all the components into the PC, where you can call RAM, hard drive, PCI slot, and also LAN card. So as you can see over here, predefined. What we mean by predefined? So I'm gonna just slide into the headline on the top of it. So you can see it, that what is about predefined. So predefined, as you can see over here, each computer, they have the network and also they are connecting with each other. So how do they connecting with each other? So the main secret of it called a LAN card. So local area network. So that each LAN card, they have a unique MAC address. So what is a unique MAC address? In example, when we communicate with one phone to another phone, there's a IMA number. So from that number, we can easily communicate from T-Mobile to Sprint, AT&T from T-Mobile, so on so. So you cannot change any such as MAC address because it's predefined from the manufacturer. And it contains 48-bit, which is hexadecimal. So I'm going to be briefly showing the hexadecimal. How does it look like? Right now I'm into this command prompt, so I'm going to type in there, which is IP, the code, which is IP config /all. So right now you can see there's a lot of information gathered together into the blackboard. Obviously over here there's the word alphabetically here, the physical address. If I can highlight it a little bit to be able to easier for you guys, right? So this white mark over the physical address, obviously this is the one we call the MAC address, the unique MAC address. With this unique MAC address, you can communicate from one computer to another. So the unique MAC address in my system, where you can see F0-92-1C-E3-56-D2. So this is the unique address, the MAC, where they communicate with one computer to another computer, the purpose of the networking. As you can see right now, over here, there is a logical address. What we mean by logical address, obviously. So the logical address, an example of, if you can choose your mobile, the provider could be T-Mobile or could be AT&T. So the logical address, the same explanations of the T-Mobile. So an IPv4 or IPv6. So now in IPv4, I have an IP address called, an example, I'm going to type it here, 192.165.2.0. So this is the IP address called logical address. So I'm going to choose this one to transfer from this IP to another IP, from one computer to another computer. So this is the logical address. So IPv6, same like that. So IPv4 contains 32-bit and IPv6 contains 128-bit. So let me show you how does the IPv4 look like. So I'm going to go to my command prompt, ipconfig/all right now. So right now you can see the physical address. Just while ago I just showed you the physical address, how does it work and what is the physical address about. So same thing, if we go a little above, you can see this is the IPv4 I have. That's my preferred IP address, which is my own system IP address, and obviously the below my subnet mask stand for SM. Okay, so right now you can see that this is my subnet mask and this is my IPv4, and then above there clearly you can see the link local IPv6 address. Right now, guys, that's what I'm talking about, which is IPv6 address. So this is the IPv6 address look like, which is in hexadecimal format. So I'm gonna explain you in briefly more in ahead about IPv6 and also the IPv6. There is a more depth explanation briefly, and it's a very big broad topic about it. So I'm gonna come back later on. So right now I'm gonna close this one. I hope you understand where I'm coming from about the physical address and also the logical address. And obviously I have to explain you this one, the user defined. So user defined, obviously this one predefined and this one called user defined. So the user defined, where obviously you can change your IP address again and again as much as you want, but the MAC address, which is the local area network, you cannot change. So this is about user defined and predefined. So I'm going to wrap up this one. Okay. So now I'm going to go to right now over here, the Cisco Certified Network Associate 200-301, the main website. You can go on cisco.com, www.cisco.com, and the page will come out, and right away you can see the pop out, the duration 120 minutes and available languages, Japanese and English. So right now over here you can see an exam topic, register near any kind of Pearson view. If you want to go to do your exam, you can click it and it will tell you where you can look at, and you can go sit for exam and sample of the exam question. You can have a practice little over here. Okay, so I have downloaded the PDF format of the CCNA exam of 200 and 301. So right now, as you can see over here, 20%, which is contained with network fundamental. And also over here, network access 20%, which I mean all the question will come up, and that's how they explain that each topics they will take out as a percentage wise. And obviously you can see over here IP connectivity will cover 25% and 10% of IP services and 10% of automation and programmability. I beg your pardon, I forgot to also explain you security fundamentals of 15%. So please go ahead online and also download this PDF and briefly read all the descriptions about CCN exam, the volume 1 200-301. It will give you a broad idea about CCN. It's very easy, very simple. This is not a rocket science. All you have to do hard work and keep practice going on. That's all about it. Okay, so right now I'm gonna go to my CCNA lab that I have already explained you about this one. I have to understand. So my next topic about chapter 2, which is I was explaining a while ago that what is IPv4, which is the Internet Protocol Address. IPv4 contains 32-bit. So viewer, as you can see on the top of it, that I have written over here IPv4 32-bit. So the bit obviously stand with 0 and 1. How does it work? Because 0 stands for off bit and 1 stands for the on bit, which is value. The 1 has a value and the 0 has no value at all. So the binary format, if we divide it as a 4 octet, and it stands for 8-bit, which each octet, which calculating, which is 4 times 8 comes up 32-bit. Okay, so as you can see right now with my mouse point that there are 8 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. So all these are 0. We can compare with this 0 of bit, which has no value, right? And over here we can see 1 1 1 1 1 1, so on so on, and we have all the 1 contains 32-bit, same thing, and which is on bit, which has a value. And octet, so as I explained you a while ago, that octet, so what is octet? So each portions contains 1 octet. That's what we call octet about. So 1 octet, 2nd octet, 3rd octet, and 4th octet. Now all these octet combined, same thing, 32-bit. Right, there are 3 types of numerical alphabets and also alphanumerical, the program we use for in related to binary. Okay, so what happened? We always use a numerics for IP address, Internet Protocol, to be able to format into the binary so that the language understand, the computer understand, so that they right away communicate with other computers in purpose of the networking, purpose of the resource share, so on so. Okay, so these are the 3 types that we use for the computer. So alphabets, numerics, and alphanumerics. And also I have to explain you another thing. As you know that I have explained you about on-bit, off-bit, about IPv4, how does it work, octet, so on. But you have to know one thing also, which is that from 0 to 255, you cannot exceed from 0 to 255. So from 0, 1, 2, 3, 100, 150, 200, all the way 254 IP address is a valid address. If you go for such as 256, it has no value at all. So you have to know that there is a limit. You cannot exceed above 255. It cannot be 256 at all. So guys, again I'm telling you, from 0 to 255 the IP address has to be. Okay, so I hope you got this the clue about IPv4, which is content 32-bit, and I have divided as into each octet as a portion, and on bit, off bit, and how does the binary work from numerics IP address. So it's very easy. It's not a rocket science, again I'm telling you. So all you have to do is just understand. Please, if you don't understand, email me, and I have a WhatsApp number as well. WhatsApp me, I'll right away help you out from that. Okay, so I'm going to cross this one. So now I'm going to go to number 6. Okay, so number 6, that I have designed this lab in explanations about the class, the IP address class. Okay, so how IP address class work? Okay, so there are 1, 2, 3, 4, 5 classes in total enter the IP addresses. Okay, so class A contain from 1 to 126, class B from 128 to 191, and class C 192 to 223. So as you can see, I have circled it all the way from A to C. These are the one we use in every day-to-day purpose of the IP addresses. Okay, but class D it's for multitasking. Multitasking, which is like multi work if you want to do for heavy work for company, manufacturer, for one country. It's a big huge work that gathers called multicasting work. Okay, and the class E is for the researching. It's about the also researching and scientific and more depth in it, goes into the government ethics side. It's more broad topics, so we don't have to use E at all. So class D, not at all. So we have to use only from class A to class C, which is the IP address class. Okay. Now, as you can see over here, how I have get from all the octet decimal to the binary format, right? And as you can see over here, all the 0 contain 0, which has no value, and all the 1 has 255. So these are called subnet mask, means SM subnet mask. So if I can type for you, subnet mask. Okay. So this is the subnet mask that I was talking about a while ago, which is same thing, same goes with the subnet mask. If the 255.255.0.0, if you see in the subnet mask, it's like this. Right away you have to find out how am I gonna get the binary format from the subnet mask. So right away you have to contain from 1111181, which is obviously has no value, 00000, which is 80.00000 dot so on. Okay, so that's how you can get an algorithm calculation from the subnet mask to the binary format. Okay, if I can a little bit make it bigger for you, we'll be able to see it properly. Okay, so these are the subnet mask I've explained to you guys. I'm gonna make a fresh page right now. We'll save it. Okay. So I hope you understand about the IP address that class contain A, B, C, right? So once you keep practicing, believe me guys, you'll be able to totally memorizing it and super fast. There is no doubt about it. Okay, you can implement so faster once you keep practicing. So practice makes it perfect. That's what we will learn about. Okay. All right. So there's one explanation that I haven't explained to you, which is 100.200.150.9. So if your IP address have such as this one, how are you gonna get the binary format from that? How are you gonna get the binary out? So this is the binary format: 1, 2, 3, 4 octet, which is 1 8-bit, 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 and 8-bit. So how I did it? Let's go and explain about it. Let's go to the lab. So as you can see right now, I'm in my lab over here. So I'm going to type here 100.200.250.9. Okay, this is my IP address, and I want to get this IP address as in binary. So I want to get the binary out from it. Okay, so I can type here binary. Okay, hello. All right. So let's calculate. So 100. So we have to understand first of all how we can get this octet 100, 200, 259. What is the formula of it? So we have to learn. So that's the reason I'm not gonna go explain the binary, the format. Before that, I have to teach you the format from the octet, from the 100, 200. How does it work? How does the binary information work? Okay. So let's go get into my another lab, which is over here. Explanations here. Okay. So I have another example here, so I'm gonna come back with you guys, but this is the example of it. So this is my another IP address, and I can easily showing you guys that this is the first octet, second octet, third octet, and fourth octet, right? So this decimal value, the IP address in the decimal form, and right away we get 32 bits divided into 4 octets. You can see the explanations and how does it work. So right now we're gonna be showing you how we did work this formula. Okay, so this formula works in the decimal 100, 200, 250.9 to the binary. So, and over here you can see that I'm going to type now 2 to the power 5, sorry, 2 to the power 6. I'm sorry, having a little trouble about with these contain just the text, it's a little like a mouse and touch pen drive little issue, so I fixed it now. So 2 to the power 5 now, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, and the last 2 to the power 0. Okay. So viewers, as you can see that I'm going to be calculating the format, that how does the IP address, the algorithm, and the math will work it out. So I'm going to be explaining right away right now, which is that 2 to the power 7, which is 128, the result. 2 to the power 6, which is 64. 2 to the power 5, which is 32. 2 to the power 4, which is 16. 2 to the power 3, which is 8. 2 to the power 2, which is 4. 2 to the power 1, which is 1. And 2 to the power 0, I'm sorry, 2 to the power 2 to the power 1, it's 2. Big button. And 2 to the power 0, which is 1. Obviously, 2 to the power 0, which is value, which is only 1. So this is the main the formula that we always follow, and please you have to memorize it. Okay, so from all the way 208 to 1. So that's how you calculate when something must come, CIE value, class A, class C, class B. A lot of something mask is coming at the ahead classes. So I'm going to be explaining more in depth. So first of all, you have to know the formula about it. Okay, so 2 to the power 7 is 128, 2 to the power 6, which is 64, 2 to the power 5, which is 32, 2 to the power 4, which is 16, 2 to the power 3, which is 8, 2 to the power 2, which is 4, 2 to the power 1 is 2, and 2 to the power 0, which is value is 1. Okay, so now I'm going to be explaining you guys, obviously, that I have my own lab, as you can see, that how I worked with 100, 200, 250 and 1. Okay, so now let's work with 100. How are we gonna get the 100 binary? Okay, so now start from 100. Okay, so number 1, so we're gonna calculate this way. Number 1, so we get number 1 here, just to make sure more easier for you guys. 1 1 1 1 1 1. So these all have a value. Okay, these all have a value. That's why we only 1 bit. Okay, all right. So now I'm gonna go 100. erase it little because I'm going to put in one row. So now 100. How are you going to get the binary of 100? So we have to first of all look at 1. This is the 1, okay? So 128, so there is no value. 64 has no value. 32 has no value. 16 has no value. 8 has no value. 0 has no value. 1, 2, 3. If I go back again, so 128, the 1, which is no value. 64, yes, we have 64, which is one bit from here, okay, and as you can see from 32 has a value. So 64 plus 32, 64 plus 32, okay, we have these two values, and then we have to go 16, so if you can calculate, okay, so now 64 plus 32, we have 96, okay, and 96, so we have these two values, 64 and 32, and now we're gonna go 16, no, 16 we're gonna have no value, so we're gonna be doing here. So 0, 64, 1, which is this one, have 1 bit. 32 has one other bit. 16 we don't have to, because if we calculate 16, 96 will be exceed 100, okay, so we have to put off bit. Then 8 still is off bit, because if we plus 8 with 96 still exceed 100. Now 4 still off bit, because nope, I'm sorry, I made a mistake. 4 could not be off bit, 4 should be on bit. Because why? Now if we calculate from 4 plus 96, right, and right away it just gives you the result, which is 100, and we are almost in 100, okay, so the 4 is 1 on bit, 2, 0, 1, 0. So now if I'm calculating over here for you guys more clearly, so which is over here 64 plus 32 plus 4 is equal 100. So now I have to plus over here with 4. So viewers, as you can see, because obviously I have given a little broad a depth lesson to you guys, so that's why just taking a little long. But when you're practicing over and over again, what happened, you will have a very easier way to do it. Once you keep doing it, practicing it, you'll be memorizing it so fast. You don't have to calculate so much to the power 7, to the power 6, because also as long as you know 128, 64, 32, 16, 8, 4, 2, 1, that should be enough. That's how you can calculate from it, okay? So we got the result of 100. Now we're gonna go the 200, okay? So let's calculate for 200. So we can find out from 100. Let me get my calculator. Okay. Now, so 128 on bit, yes, it works, which is 128 plus, and 64, yes, on bit, it works. Okay, and plus, which is 128 plus 64 plus 92. So we need 8 more. Okay, so we gotta put next one 32. If we put plus 32, it'll be exceed over 200, but we don't want that. So we're gonna put 0, this value. 16 is not gonna work, and 8, yes, we need 8 because 8 will work and work it out with 192, 200. So guys, as you can see now, I'm gonna put here digit 8 equal 200. So I'm gonna now explain the binary format of 200. Okay. So now, as you can see, the binary format of 200 here, which is, to erase it again back because I have to get text format here. So 200, which is obviously here, as you can see, 200 we calculate from 128 bit, so we take 121 bit, then we did take another bit, 1 bit, which is 64, but we did not take 32 bit, as you can see, so it should be 0 bit, which is off bit, right? We did not take 32 bit, right? And now we're gonna go 16. We did not take also 16 bit because it should be off bit, and 8, it's an on bit because we add with the 192 with 8, it comes up, which is 200. So now we have to press on bit for the 8, and 0 for the 4, 0 for the 2, 0 for the 1. That's for the 200. Now let's go for 250. 250, that's equal, which is the reference, the formula. So we're gonna on bit 128 because also it's still within 250. Now we're gonna put another on bit 64. So let us calculate 128 plus 64 plus, so 32 bit, yes, we can take 32 bit because it's still within below our 250, so we can press 32 bit here. 16, yes, plus 16, we can take 16, still 2040 below our 2050, press on bit, and 8 plus 8, 2040, still on bit. 4 we cannot take because if we plus 4, if you're trying to put like on bit for the 4, it's not gonna work because you'll be exceed over 250. So that's why we're not gonna choose that. We have to put off bit 0. Number 2, let us calculate plus number 2. Dear viewers, as you can see, the result of 250, which is the result out of it. So we have to put on bit for number 2 and number 1 for 0 bit. Clear. For number 9, so we have to include like this way. Number 1, 128, 0, 64, 0, 32, 0, 16, 0. We can put 1, 8, 4, 0, 2, 0, and 1 on it. Let's calculate as a 9. So we took 1, 8 from here, 8 bit as on, and rest 2 is off bit and 1 is on bit. Plus it, 8 and 1 plus 9. So now we can get the result here, which is 250 and 9. So guys, as you can see, over here that 100, 200, 250 and 9, 100, 200, 250 and 9. We had purely a little math over from the decimal to the binary. So I hope you understand. Have a look onto it, keep practicing it over and over again, and you'll be able to frequently memorizing it easily to be able to do any kind of decimal to binary. So I'm gonna wipe this off, or I can go down. I will wipe it off, get a new. That's it. Okay. So now I'm gonna go to the right away to my lab that I've explained to you, that over here 128, 64, 32, 16, 8, 4 and 2, so which is one binary and one decimal. Okay, so I've explained more that how we can get from 10 decimal to binary, 15 decimal to binary, 30 decimal to binary, 15 decimal to binary, 30 decimal to binary. So you can, if I can zoom it a little for you, so you can easily see it. For 10 you get it 0, 64, 0 from 128 to all the way 16, 1, 2, 3, 4, and we on the 8-bit 0, 4, and right away 2 is as a class and 8, which is 10, 15 same goes, 30 same goes. Across this one, and I've also explained to you guys before I go moving forward that the IP address classes, which is class A, class B, and class C, and also in explaining about class D and class E. So I hope you understand about this. So this is how we get the from decimal to binary format. That's how you have to calculate algorithm, so on. So okay, I'm going to close this chapter. I'm going to close this calculator. Now I'm on my lab. Now I'm going to go to my lab right away. So I'm going to be explaining about the IPv4 also, that you have also know about this. While I showed you that the bit represented and how does it work and how does octet to IP address decimal format work, and decimal form for easy format and readable computer understand only binary still in use. Obviously we explained that computer always understand the binary. Okay, and also you can see the bit is represented by 0 or 1 binary. Okay, so IP address is in binary form 32 bits, and all the zeros are off bit, and all ones are on bit. First octet, second octet, third octet, fourth octet. These guys keep reviewing and reviewing over and over again. You'll be able to frequently memorizing it easily. Okay, I'm gonna go number 4 now. Okay, same thing, minimum number in each portion, which is same thing, 0 stand for 0 binary. Maximum number in each portion, 2555, which is all these are on bit because 255 has a value. That's why we turn on all on bit in a binary. The range of IP address value I teaches you that from 0 to 255, it cannot be 256. Okay, you must know about this. More than 255 is not applicable, as I told you a while ago. Check by 120. If you just open, write down in your notebook and practicing on it how to get this binary out, you'll be able to easily get it out. So total IP address range IPv4 is 0.0.0.0 to 255.255.255.255. That's the subnet mask of the IP address. Okay, so if you have a 0.0.0.0, the IP address, and you're gonna get the subnet mask over it, which is 255.255.255. That's over on the top. Okay, so now we're gonna go to the chapter 7 over the lab. Okay, I've explained to you a while ago also the class A, class B, class C. So now, class A, how we can work in class A, 255.0.0.0.0. Okay, so 255, all these on is on bits. Remember I told you 255 has a value, it's an on bit. 0, all the 3 0 you can see it has no value, so it remains 0, 0, 0, 0. So you can see also I put it on in my lab on beat for the standing order for 255 and also on, and rest of it all beat. And I put a network because obviously 255 is in network, and all these are host beat. All these are host beat. So that's why I put n.h. So H stands for host beat. Okay. Class B, same goes 255, 255.0.0. So 255 is our on and 2 zeros are off, and that's why I put 255 standing in a network and 2 zeros standing in host beat. Class C, same goes. Okay. I'm gonna go my chapter 8. So chapter 8, the same thing, that IPv4 class ranges I've explained to you. Class A from 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, and obviously Class E 240 to 255. Okay, so I have explained to you all those, and as you can see that Class A, Class B, Class C, we can work with LAN and also WAN. So I explained to you a while ago, LAN stands for local area network and WAN stands for wide area network. I'm going to explain to you about wide area network later on, but I've also explained to you LAN. So LAN, also I've explained to you LAN, as if I can go back to my lab and you can able to see if I explain to you LAN or not, which is this one, if you guys can remember it. So these all 4 computers in a local area network, which is LAN. If this computer is in New York, if this computer is in Australia, if this computer is in London, this computer is in Japan. So what happened? These are all contained in a wide area network. But as you can see, they are all stuck with each other in one geographical area, which is of course called LAN, local area network. Okay. So can go back to my topics. Yeah, so that's what is about LAN and WAN, and we explained to you Class D multicasting and Class E for reserve feature research and development, so on, as I explained to you too. Thank you so much, and I'm gonna go now to my chapter 8. Oh, I have explained this one. Chapter 9. Now I'm going to be a little explaining to you guys about the types of the data communication. Okay, so remember I have explained to you a while ago in this lab that they communicate with each other, right? So I didn't explain you how they're going to be communicate with each other, which way, how, and what not. So this is the one we can give an example. So they will communicate with each other a setup of rules, right? An example of unicast, one-to-one, broadcast, one-to-all, multicast, one-to-group. So what is unicast? What is broadcast? What is multicast? I'm going to explain to you right now. Okay, that's my broadcast. That's my host path. That's my multicast. That's my unicast. So dear viewer, as you can see right now that unicast, what we mean by unicast. So unicast stands for one-to-one communication in a network. I'm sorry. So one-to-one communication in a network. Example network type. Most communication is default one-to-one communication. So if I can give an example in another lab. Welcome to Cisco Packet Tracer. So one computer, there is a one computer. So I'm gonna get the extend with the fast Ethernet cable. I'll explain you about what is a fast Ethernet cable and about this lab. So I'm gonna come in next class session. Okay. So this one computer, which is DC1, and this one PC2. So now as you can see, PC1 and PC2, they are communicating with each other because they're in a one peer-to-peer, which is Unicast. Okay, so as I have explained to you a while ago, that in my explanations, one-to-one communication in a network, right? So this computer, they're communicating with each other. That's called Unicast, right? Same thing. If you talk about, oh, what about switch? Okay, same thing. So if you get the switch, right, and you get two computers here, right, and if I disconnect this cable, and if I get cable range from here, and I connect from switch, first Ethernet, I'm going to connect, this one, also this one. So if you can have a question that what about, you know, switch, the same goes, they're in a one Unicast, right? So basically this one sending a data from here to there, and this one sending data to here to there, this one sending data from here to there. So that's how it going, you know, that goes in a one Unicast. So that's what we call Unicast. Okay. So guys, I hope you understand about the Unicast. What is Unicast about? The most communication is default one-to-one communication. Okay, that's called Unicast. Now we're gonna come to broadcast. The broadcast communication. So broadcast communication is one-to-all communication in a network. Example: 200 devices connected in a LAN. Universal broadcast address is 255.255.2. So obviously I've explained to you a while ago that broadcast, that, you know, the subnet mask of 255, which is on the bit. So, you know, I just mentioned here universal broadcast address is 255.255.255. So suppose now, how does the broadcast work? One-to-all communications, right? So suppose now I have here one switch. I'm gonna disconnect it, right? I have here one switch, so I'm gonna connect everything. So suppose I have a one switch here, I have a one computer here. So now I'm gonna get another computer, laptop here. I'm gonna get another laptop here, and I'm gonna get another computer, another computer, another computer. So I have mentioned over there more than 200, right? So just example, you have over here 200 computer, laptop, and everything, right? So get the cable. I'm gonna get this one connected. Sorry. Get this cable connected. Get this cable connected. Get this cable all the way to connected here. Get this cable to connected here. This cable connected here. So now, what is broadcast? You know, about that I have mentioned to you a while ago, the broadcast communications, which is one-to-wall communication in a network. So now, if you wanna you know, send from PC 4 to your all the way 199 computer, right? That's called broadcast communication. So you want to send one file from here, it'll go there, it'll come here, it'll go there, come here, go there, come here, it'll go there, come here, go there. So that's how we'll be passing on to each other from one to all the way. So from 1 to 199. Okay. So now what I'm explaining to you that the broadcast communication is from one computer to 199 computer. If you want to send the file, data, anything, it's just spreading all over it throughout the switch. That's called broadcast communication. Okay. So I'm gonna cancel this, make it a fresh page, right? And now I'm gonna explain you about the multicast communication. So what is multicast? Multicast communication is a one-to-a group communication in a network, in example network. Of course, suppose 100 devices are connected in a LAN. Total 10 group you have, okay, each contains 10 devices. Example, video conference, online live streaming, so on. Okay, D class also contain with multicast traffic group. Multicast, is not included into CCNA course. We cannot use it LAN or WAN check by putting 224 in first portion of IP address. So I explain there. So the brief explanation, which is one to a group communication called a multicast communication. So if I can example to you in this Cisco packet tracer. So I have one switch here, I have another switch here, I have another switch here, I have another switch here, right? So I'm gonna put my this switch as an major. I'm gonna put this computer as an accounts, this one as a cell, and this one I'm gonna put as an marketing and teaching. So you see, I have a 4 different group in my one office, right? So as you can see that assume that you have each department you have 4 computer. Okay, 3, 4, 1, 2, 3, 4. So you can see I just made a group, which is obviously a multicast. That's what I want to explain about it. So now if I'm gonna get the the cable from this switch are connected, from this switch to this switch connected, from this switch and this switch connected, this switch come here connected. As you can see that one office, right, first floor, third floor, second floor, fourth floor. So I have a fourth floor over here, right? So fourth floor, they are connected with each other, the switch, and then each department they have a 4, the host, which is the 4 computer, 1 person, 2 person, 3 person, 4 person. So now suppose Mr. Jack, he just want to send one file to Mr. Harry over here, right? So now Mr. Jack, this is Mr. Harry. Okay. So if Mr. Jack want to send to Mr. Harry a file or data or any kind of resource, right? So he has to go all the way from switch, right, or router, okay, and then the router or switch will transfer the data to this one, and this one will go to send it to here, and this one will come back to here to there. So that's how the multicasting the group works. Okay, so assume in our office there are 4 department, 5 department, 6 department, could be 10 floor, and then one geographical building. You have set up the rules, and you will work in a group that's called multicasting communication. So you're communicating with a group, a set of a group, the rules of a group. Okay, that's how it's work. The CCNA class right now, and I hope you enjoy this class, and I'm really appreciated that with the patient you just sit down or stand, whatever it is, you're patiently watching this video. Please practicing over and over again. Feel free to contact me, email me for any such as you stop or traffic you have, you right away knock me, I'll answer you right away back. I promise that. Okay, so that's for today now, and I'm gonna wrap up these topics today, and we'll wait for the next session of day 2.